Hello, everyone, and welcome to another Grafana Office Hours. It's been a while since the last one, but we are back and we're going to be talking all about Loki. But first, I'd like to introduce you to my new colleague over here.
Ooh, thank you, Nicole. I think this is quite fun because I used to be an avid watcher of Grafana Office Hours. So now that
Oh,
I'm the co-presenter host, this is a bit different. So I'm buzzed for my first time. But hi everyone, my name is Jay Clifford, and I'm one of Nicole's colleagues. Actually, wait, I should put it this way, mirroring. There we go.
yes. No, it's funny because now you get to see how little there is to prep before these. Now you get to see it warts and all. But today I figured that I would have not just Jay in you, but also over here, Ed Welch. Welcome, Ed.
Thanks for inviting me. Looking forward to talking about my favorite software project.
Yeah. Well, not like you're biased at all or
Completely.
anything.
Usually I qualify my opinions as being completely biased, so I'll just kind of set that stage for the whole show here, I guess.
Yeah. So tell us what you actually do and why we would invite you here to talk about this new project you probably haven't heard about called Loki.
Yeah, absolutely. So today I am a software engineer. That is predominantly what I've done for my career. Done a bit of different engineering along the way, and actually, even at Grafana, I did some management for a while. Largely because I think I just sort of fill the roles and do the things that are needed, and kind of have always adapted to. So I'm kind of pretty good at a lot of things and not great at anything. So specifically though, at Grafana, I started. You do the math in my head, probably about 5.5 years ago now. So Loki as an idea was born just about 6 years ago, and it was sort of announced to the public in I think November of 2018, and I started with Grafana in January of 2019, and have been working on the Loki project since that entire time. So that puts me as I think the first engineer officially on the project, and it's been quite the journey. So but yeah, that's kind of my background in a nutshell. I do tend to always end up towards engineering, but kind of more of a tinkerer than I think we have better engineers than me on the project now, luckily.
So how do you mean? You said you were the first engineer officially on the project, but it was announced before you joined Grafana. So how does that
Yeah.
work?
Yeah, so David Kalschmidt and Tom Wilkie kind of created the idea, and we can kind of dig into that idea too, but I'll give you a little bit of the story of the folks involved early on. So Tom and David kind of worked with the idea, and then there were a couple of engineers at Grafana. At the time, Grafana Labs was, around 30 people, I believe. So there were a couple other engineers that were working on like the Cortex project, which Loki gets its a lot of its origins in. I mean, Loki uses, or at least used, Cortex as a library of sorts. And so some of those engineers, like Gotham, I haven't tried to pronounce your last name in a while, so I'm not going to try now. And like Jacob Lissy and some other folks that kind of were involved with the project in early days, that were sort of borrowed engineers. I just hired in and essentially, from day one worked on Loki, and I have been associated with those other projects along the way, but my focus has always been around Loki.
So how much would you say was done at this point? Was this very much like a proof of concept document, and then you really started committing code, or like
Yeah, it's funny. Like there's some elements of Loki that exist today that are still code from that, but it's pretty small at this point. Like Loki, sort of shares in the concepts of the idea. Like I think that's when it was announced, nobody really had any idea if the project would succeed or become popular, right? Like the announcement was about this sort of concept. At the time, it was a bit funny because we ran a cluster that we called a production cluster, and had like and like an unlimited free beta period or something like that, and we were just kind of hoping that nobody took us too seriously the unlimited parts of that. But Loki, you know, very early on was really the idea of maybe this is a good sort of segue to kind of to talk about that, right? So the year is what I said, 2018, and I kind of frame this a bit because I'm going to talk about Kubernetes quite a lot, and Loki is not particular to Kubernetes, certainly not anymore, but it is a big part of why it was created. So, you know, I always want to phrase that a bit because I don't want to steer people away if they're not using Kubernetes. There's some cool things about Kubernetes. There's a lot of things that are, I mean, they're cool, but you know, there's always some additional complexity there. Anyway, Kubernetes and Prometheus are like becoming a lot more popular, and in that space, there wasn't really a great way. So you have this very nice solution in Prometheus for getting metrics out of your applications, coming with, I think, one of its most powerful features, which was service discovery, making it, you know, sort of trivial to, you know, use this dynamic environment of scheduling, descheduling pods and getting, you know, one of your telemetry signals very, very easily. The same wasn't really true for logs. It was kind of hard to, you know, there existed solutions, but, you know, nothing that had been really built for this kind of world. And so that was one of the criteria around Loki, was making it sort of fit into a Kubernetes native world very easily. So that same kind of service discovery and getting your logs without having to think about it, aggregating them all in one place. And so it borrowed the concept from Prometheus of labels. So this sort of key value pairs that become metadata for finding your logs. Like, now we use labels a lot differently than Prometheus because we don't really want to store any cardinality in them. So we really just want very, very simple labels to define the source of log streams to make it easy to find your logs at query time. We can talk a whole lot about labels, but I'll skip it for now. So because it is kind of the key component to how Loki was built as a database, because it's the index, and you know, index is a complicated thing in a database world. And that was another thing with Loki, was this idea of keeping it very simple, or as sort of simple as we could or can or try to simplify a lot of operations. So that was kind of the second part, was, you know, we wanted something that was native to inputting logs very easily into a system, but also that would run and was built around, you know, the sort of things that we knew about building distributed systems and scalable compute in 2018. So it's built as, you know, microservices components. And then really the key to what Loki does is use object storage to take a whole class of problems and offload them to systems that are very well built for those problems. So you don't have to worry about running out of disk space. You don't have to worry about scaling your disk infrastructure or monitor, like nothing related to disks. If you've ever been in a position in your job, in your career, where you've been paged because of disk related things, like, you would appreciate how nice this is. Disks are really awful. I mean, obviously we need them, but I like it a lot better when they're abstracted to me through an HTTP API, like what object storage does. So Loki was built to be simple. Yeah, go ahead.
You mentioned that Loki is a database.
Mhm.
Why would you need a separate database, like a log specific database? Because there are already lots of databases.
Yeah, good question. So this one is fun to me today because, you know, if you asked me this a couple years ago, I think Loki's identity it felt a little bit more solidified, but I think it's evolving again. And, you know, the reason I referenced that is because the way I would have answered that question before, and it's still what's true for today, is that Loki makes trade-offs around the type of data and how we expect it to be used. And no database really gets anything for free. So these trade-offs sort of determine like what it's better at, and better might mean cheaper, or, you know, more cost effective, I guess is a nicer way to say that, but really cheaper. Better might mean faster for this or faster for that. And so the trade-offs that Loki was designed around were very simple ingestion. So there's no schema requirements. We don't have any opinions. Loki, you know, does not care what format your logs are in, if it's a consistent format or not, because the reality of the world of logs is it's sort of a huge nightmare. Like there's sometimes structure, usually not. Like, I mean, people can maybe agree on a formatting like JSON, but that does nothing to sort of standardize on a schema within JSON of common keys and values. And so there are databases out there that are very good around working with schemas. And the trade-off you make there is you have to normalize your data to ingest it. So we didn't want to do that. And this sort of differentiated it from some of the common log players at the time. Certainly not all of them, but and then also leveraging object storage and small indices by design so that we can leverage parallel computing and horizontal scalability as another trade-off for how it costs, like sort of what the cost trade-offs are on running software and infrastructure. Like it's actually cheaper in most cases, even to pretty impressively large scales, to do more brute force searching with dynamically sort of scaling infrastructure than it is to build and maintain a really large index that requires machines that have hundreds of gigabytes of RAM, or the complexities around how you maybe shard an index across machines. So the trade-offs Loki was built around were to simplify a lot of things in exchange on the ingestion side, and then add basically a query language that lets us do, we call a schema at query. It's sort of the idea of like use a parser to extract the content at query time, and then you can write your query to kind of normalize your data. However, that means those queries require more resources, right? And so those trade-offs, they tend to work well for what we built Loki as a target audience, which is people that run infrastructure, right? I'm a developer. I need to know if my stuff is working. I'm, operating some software. I'm on call for it. So, making it quick to find your logs, to find your problems. But there's a whole class, there's several classes of other use cases around logs that exist. Two of which I'll kind of call out, like business intelligence, like, give me the distinct, the count of orders that, went through, or like how much, people log so much data. I don't know that this is what logs were meant for, but like people will, log financial data and transactional data and things in their logs, and then want to do analysis on that, as part of their business analysis. And a lot of those queries ask questions that, especially over really long time ranges, that, Loki has to work harder to answer, because we didn't pre-compute those values into an index, right? So we go scan all that data and read it. So, so the interesting part about like where we are today is, we find ourselves more and more interested in use cases which, Loki wasn't originally built for. And now we're trying to decide, should we extend it, right? Add more levels of pre-computed indexing, or store data in different formats like columnar storage, or things that have some advantages for specific access patterns. But that's really the key with databases, right? Is they're usually built around their use cases, and that sort of determines, how they store data and what they're fast at or what they're slow at and what costs them money. So at the time, Loki didn't, there wasn't really a system quite like it, that was built around, like a microservices architecture, leveraging commodity compute and horizontal scalability and object storage and schemaless ingestion. So we built it, and it turns out that scratched an itch for quite a few folks.
Can I ask you some? So I feel like you've touched on a lot with I think this is the main thing that drew me to Loki, was like the schemaless design and how you store this in object storage. So, but then I feel like having built this, you've done something different. So it comes with like a ton of terminology differences. And it'd be good if you could sort of like explain some of that. So, we've got terms like log streams, and then we've got chunks, and then we have labels, and then we have, and like, how do chunks relate to labels? How do they relate to log streams? And, all of that good stuff. And I just, for me, it'd be great to hear how you describe these.
sorry, I'm only laughing because I've probably created all of these problems over the years as I've like. There's a common problem that I've run into. I think folks run into. It's like when you're new to a field and you don't understand the terminology, it's like pretty daunting, right? And you sort of try to learn it, and like problem that I have is when I learn it, then it's like, oh, that's all I'm going to use now is that terminology, and I sort of forget about my former self that didn't know those things and didn't have them well defined. And so it is confusing. And then if you throw in that there's a lot of overloading of terms, especially if you use a word like block or chunk, even within the databases that Grafana builds, those terms mean sort of similar but different things. So yeah, let's start with a few of those and see if we can I can tell as
Maybe
much of
we
a
could
story
start
about them as you'd like.
with
But
an index, because that's something that's common across all
yeah,
databases.
so this is funny because depending on who the audience is, again, I will give you my definition. And I'm sure there are people that have other definitions. I am not sort of by education a computer scientist, so I've learned stuff through others and through anyway. So an index, if you think about I guess I can explain it in Loki terms, right? Like if you have a whole bunch of log lines, and they come from a whole bunch of different applications, and you want to go look them up, right? So the most sort of basic index usually is like, if they're stored on a file system in files, you would navigate that file system like the directory structure. Like that's an index of a file system. Like file systems have, internally they do really wild stuff now too in terms of optimizing that. So like if you have a lot of files in a directory, they can, sort of make anyway. What an index does is take a large set of values and reduce it to a smaller set of values based on any of a zillions of a criteria. Like in Loki's case, we take that huge amount of data and simplify it into some key value pairs that let you, go find it again, right? So like env equals prod, app equals Loki. If you were thinking of like a reverse index, which is pretty common for a search engine. This is like the index in the back of a book, right? Like I go look for a word and it tells me what pages they're on. And so when that data was put into that system, every word is sort of stored in a separate file, and then the references to where it was found. And so this is very fast for search, right? I go back and I look at that index, but it can also get huge. Like that index can be as big as the data that you ingest, because every word is going to get stored with multiple references to where it's found. Now, these are very simplistic descriptions because a lot of really smart folks have found really, really clever ways to like optimize these things and build levels of levels. But, effectively what you're doing, like, if another common case people come across stuff like this is in like a, relational database, where an index is a way of taking different columns and sort of pulling their values out into a separate place where, maybe even you do some math operations on them. But the idea is to make a smaller data set of a bigger data set that you can look at the smaller data set faster to narrow down where you might have to go search in the bigger data set. Or even completely answer your question from the smaller data set. So that's how I define an index. So
yeah, so I kind of think of it as like I kind of think of it as, let's say there's a whole bunch of physical addresses for people and businesses and a bunch of whatever else is there. And you could just look, if you were looking for something in particular, you could look one by one. But an index is kind of like breaking that apart into different categories. So you could do it by suburb. You could do it by like whether it's a business or an individual. You could do it by location. You could do it. I mean, you could do it by house number. You could do it by street. So there are some ways to break up that data that are better than others. So for example, there's probably a 1, like the house number 1 for many streets. So is that really like you could do a search for all houses that have the number 1, but is that really relevant? So an index doesn't necessarily mean like it's a good way to organize, but it is one way to break up that data. Does that
Yeah,
sound
so
right to
you
you?
touched on a thing that I'll pivot into like, distributed systems 101. So what you just described there was what I would call key spaces. So in your index there, right, you have a key space, and you described several of them, right? Like it could be, you could have a key space that was based on street names. You could have a key space that was based on house numbers or zip codes, or I guess zip code's a US thing, but there's equivalent, right? Like first name, last
We have
name,
zip
and
codes too.
yeah. Do they call them zip codes though, or is that just a um
Well, no, I don't know. We have postal codes.
yeah, right.
Postcode.
The zip part. Anyway, so you have these key spaces, and what's really fascinating for a distributed system is you succeed or fail by how uniform the access patterns are over the key space, because what you end up building, and this is all a distributed system is a way to split work across multiple machines using a key space. And so, for example, if maybe a bad key space here would be if you took I don't know, let's say you took last name. I mean, this is actually not a great example of a bad key space. It might work all right, but where they tend to break down is if all of your access pattern goes through a very small number of keys. You want the keys to evenly distribute the work over all of your infrastructure, because you end up basically sharding is the word we use constantly. So sharding is splitting data up into smaller shards. And you do that by taking, so if you took postal codes would be a pretty good example, because they're basically built for this purpose, right? They're designed to divide up the address key space uniformly across the whole physical world. So in theory, now where that can go wrong is like if you have a postal code for like one major city and 99% of your population is in that city, now that city basically becomes one server in your infrastructure, and it's doing all of the work all of the time, right? So you this is the sort of name of the game. So for Loki, our key space is the key value pairs you assign to a stream at ingestion. So in practice,
Wait,
this
so
works.
now what is the difference between an index and a key space?
I would say an index is like a method of storing a key space or using a key space. So they're it's a little ambiguous in that sense, right? But a key space is going to be part of the definition of an index. Like an index will have a key space. That sounds reasonable to
Okay.
say. I'd have to think about if that's universally applied or
Now,
not.
how about a label? Because Loki does use indexes, but it uses labels much more. But it sounds like it is just another way of organizing or categorizing data.
Yep. Labels are in our index, so Loki is not index free. Nothing really is. I don't know. We might say a little bit because it's not a reverse index. Like we don't look at the log content and take every value and put that into a lookup table, which is a type of index. Instead, we index the metadata, which are these labels, which you hear tags a lot too. So this is another area where there's a lot of overloaded, or that's not overloaded, but basically, multiple terms. But it's these key value pairs where maybe we went wrong with Prometheus and Loki, and is sort of how flexible. So like you can define any sort of labels that you want. This is true for Prometheus and Loki. And I think maybe what's interesting about something like open telemetry is they have some opinions they call semantic conventions, which are ways of specifying common labels. Because if you go between company to company, or even team to team within an organization, you might find it hard to have consistency in labeling because everyone had their own idea. Maybe they use app, maybe they use project, maybe they use system as keys instead of so it's like you have this huge flexibility here. But the key value, so as an example, if I have a web server that's running in a dev environment and maybe my US East region, it would have it could just have one label which says app equals web server, but that's gonna now mean any web server anywhere will have the same set, right? So then usually we add, cluster equals US East 1, environment equals dev, or env equals dev, and that those 3 label key value pairs define that log stream, and then that goes into Loki, and that starts filling a chunk. So it's the log streams end up as separate files on disk, essentially, or in object storage. And if you had env equals prod, even though it shares 2 of those the same, that one value change makes that another stream, and so that gets stored separately. And we do limit the number of labels. You can have several. I generally recommend using the fewest labels that you need with Loki, because we just want to, if you think about it the other way, we want them to be useful for querying. I want to be able to say, go find all of the logs for this application or this environment or this cluster, and I can use each of those labels individually or combine them to find my logs.
So you might have answered one of my other questions in there by saying stream. So a log stream is what the unique combination of key value pair labels, and that makes a stream.
Yeah. So stream is a word that we made up in Loki. So it's very analogous to series in Prometheus.
Right. Yeah.
Why did we call it a stream? I don't know. It was a log aggregation system, not a metrics database. So we made up another word. Now, though, I usually throw in that I think conceptually it helps a bit. So good stream, so good label design in Loki makes long-lived streams that live forever, right? So you want your label values to be really consistent over time. And that means you don't want label values that include data that changes frequently, like an order ID or a trace ID or something that has a very, very short lifespan. That makes a very bad label in Loki. So stream, I think, maybe helps a little bit for folks to understand you really are dealing with an infinite stream of data. Like it's always coming in, and you're compressing it and writing it out. In practice, like labels definitely churn. Like we have labels that will set the lifespan of streams, but conceptually, like Loki's really designed around aggregating all of this data, sort of sorting it into these streams that are hopefully useful, and then building up objects that are a bit bigger than or big enough that we can put them in object storage. And
so
there they sit.
A log stream is not a single instance. It's not a log line. It's like the pattern for a kind of log. Like, for example, in the address example, an address is going to have a number, a street name, a street type, a suburb, a postcode, and so on. Mm-hmm. And that whole thing is a log stream.
Yeah. So in that analogy, which is kind of fun, right? Like your stream would be what you'd be, essentially your house, right? And then basically what you would be indexing is all of the letters that come to your house, but not, you're just tracking they went to your house, right? So all of the letters that ever went to your house. And the thing is, they could be any, name, shape, or form. Like now, maybe you wanted to, this is fun for this analogy. Maybe you put up another mailbox in your house that's specifically for junk mail or whatever, right? And so like you get the post office to somehow do that, and then you add a label that's like, the log value, which is like high or junk. I don't know, making up labels again here, but then that's all of the messages ever that go, and that's a good example because that's going to be data that's consistent over time, right? So now if I'm going to go search through people's mail, I would say, I could search by, town or address, or I could do town, address, zip, and narrow it right down to a specific house. And yeah, within Loki, we're just bunching up all of those letters that come in and then putting them in objects in object storage. And then so time really becomes your useful thing when you want to search that much data, right? It's like, do I want to search for a very specific window for this mail, or do I want to search all the time for this mail? Because that is also in the index. So you can say, I want to look at this. I want to look through all the mail. I want to search everybody's mail that lives on this road for this week-long period. And that's how you would, one of the ways you could approach that.
So just to fully grasp, because I think I get this, and I like this example of city. So say if I was like, I had this project in the UK where I was going to keep in Loki all of the people being born. So a label for me would be cities, and because that would be non-changing. So I'd have Edinburgh, London, Aberdeen, and I'd rarely be adding or changing that label because they would all be a city. And then so a log entry into that stream, which would be for a city, would be each new person being born, and then that would be an entry.
Yep.
Right.
And then you could have a country and a continent and some other, labels that would give you some ability to, dimension that data for like, queries that you, I want to look, count all of the people, or, run some queries on, and Loki can extract the value out of those lines too. So if that line contained a bunch of data about, maybe the weights, you could do, what is the average birth weight of all of the people by region or something like that. Right. So, but that's you got it.
So an index, a label, a metadata, and tag, are those, do you think that that's just interchangeable, or are there semantic differences in there?
Yeah, it really depends a lot on your audience, I guess, or your, they are all sort of related to each other. Label and tag are almost synonymous. I think, it depends on systems you've worked with, whether they call it tags or they call it labels. But I think my opinion there is they're kind of sort of nearly interchangeable. The index, it does depend a bit, but they are all super related. Sorry, as an engineer, it becomes hard for me to make absolute statements because I'm like, someone's gonna argue with that.
Yeah.
Yeah, but like, you do have to abstract it somewhat and accept that you're going to lose some nuances to be able to understand something. To me, it sounds like these are all just ways to organize the data. They're all key value pairs, and they might differ in terms of the level, like how high level it is or low level, but really, it's just a way to find the stuff. It's a way to categorize data so that you can find it later.
Yep. And that is, that's the database game, right? Is there's kind of three parts of it. There's sort of how you ingest the data, and what requirements you put on people at ingestion time, and that then determines sort of the cost of that system, both in terms of its complexity to use and the resources that it used to store the data. And then you have to access the data, and you have now like the same thing, right? Like if your database was built to store data around specific access patterns, it'll definitely be faster and cheaper for those access patterns, but that requires that you know those ahead of time, right? Like it requires how people will use your system, and what data, and that can be tricky, right? So almost all databases are making these kinds of trade-offs between how much it costs to ingest and store the data versus how much it costs to, query the data. And then, additionally, you can compute, multiple indices if you want. Like, within Loki, we're sort of adding another one now via Bloom filters, which are a kind of an interesting, we even talk about probabilistic data structures, but there's this whole interesting world of things that you can do. But it is a form of an index, basically, that we will compute after the fact on the data, or maybe during ingest. We're still, currently it does it, after the fact, because we're kind of still building it and it lets us rerun it. And then you store that. And now there's another thing you can go look at when you query your data. But there's a cost to building those. There's a cost in terms of time to querying those. So, we're building those because there are specific access patterns that will really benefit from that, which is, people searching for needle in a haystack type queries, like a order ID in a whole bunch of log lines or something like that. But yep, that there is no there's no free lunch, but there are like, the trade-offs that we make with Loki to try to make it very sort of general purpose work really well right now, at least for, the world of infrastructure logs, where applications produce who knows what. Makes it very easy to ingest. And then, the access patterns that we, built Loki around are finding those logs to look through them in order to sort of find problems, or do some analysis. Like you can definitely run metric queries over long periods of times to pull numbers out of log lines and view them as graphs and things like that. But it is essentially it's a row oriented time series database, so it works best when you're kind of scanning stuff. It's not as good at trying to find a small piece of information over a huge data set, and that's why we're adding Bloom filters for one of those examples. But it's all a set of trade-offs in terms of what, because at the end of the day, like the amount of money and infrastructure that goes into monitoring is massive, and so we're always trying to find the set of trade-offs that makes things as sort of cost effective or economical as possible without sacrificing usability, and that's a hard problem.
I think that kind of is a good segue onto like the primary star here, which is like the log entry itself. And you talked on this like earlier. So we've gone down from our labels and now we talk about log entries. So you said about Loki being able to essentially store anything. So in that instance, does it almost just treat every single line like one big long string? I guess my follow-up questions here, if I was coming at a new log engineer and I go, okay, my label is going to be sysapp.log, and it's all storing in JSON, and now it's going to swap to a different format. Should I continue storing it under that label stream? Should I be different? Does it really matter? All of these types of questions. What's the trade-offs of it being one store everything type model?
Yeah, you're gonna touch on what is a really sort of hard question for any. Loki doesn't escape this. It just changes the like the idea of a schema, right? The idea it exists whether or not Loki cares about it, right? So you generate your JSON log lines and they have a format to them, right? And it's consistent through whatever time period that the application isn't changed or that produces that output. So Loki does just store a string. I think it's just an array of bytes basically. So we don't care at all. And then the query language has parsers for common things like JSON, and then a pattern parser, which is like a simplified way to do white space patterns, like the Apache common log format, which is ironically not common at all because it can be configured differently by everybody, but it's a space delimited a logline format. We use something called logFMT, which is a key value pair sort of format, and that's kind of my favorite. So the content of logline, like this is hard for everybody. We made it easy in the sense that you don't have to make any changes to your system when you make changes to your application, or if an application changes, it'll still ingest. But you can definitely break queries that were working if the log content itself breaks. And so the different ways to approach handling that, like you mentioned, changing a label, you can definitely do that. If you sort of know the time, like these problems become hard very, very quickly. And I would say we have some answers for that. And, it's hard to say, like you still have sort of query. Well, no, if you're normalizing the data on ingest, like you have to either coordinate like rolling out your application change with your schema change to your database, which is hard, or you have to coordinate your query changing over time to match. Now, I guess the advantage of changing the query is that you can retroactively do that quite easily, right? Like you can change the queries as many times as you want. Whereas the ingestion part, if you got that wrong and missed data, they're all interesting trade-offs. I don't know. I mean, I prefer, obviously by my biased opinion, no schema at ingestion. And I think that a lot of folks do because of just how chaotic the log world is. Like if you said today I'm going to build a new company and write all new software and had strong opinions around how to structure your data, like yeah, you could probably leverage some columnar storage to get advantages there. It's just in practice, few if any folks that I've ever seen are even successful doing that today. Like even if you set out today, most folks are focused on building an application that works, not how do I make sure I'm having consistent log formats over time? It's just kind of an afterthought a lot of times, unfortunately. But I mean, I guess fortunately for us, because that's why Loki's good at this.
So you mentioned that there are kind of two different ways to slice it up. You can look at it by column and you can look at it by row, and Loki is more of a row oriented database. Can you talk a little bit more about what that means and how that's different from a columnar one?
Yeah. So there are other cool database designs. I think the most common you come across in time series data. So we're talking about time series data here, which is my favorite data, which is, essentially this perpetual stream of data that is always indexed with time. So I use the word index again there, but it is almost every time series database will have indexes that use time as a because you just, it's the thing that's sort of always increasing as your data comes in. But anyway, columnar versus row. So Loki is a row-oriented database in that it receives log lines in rows and stores them, in rows in files, and then puts those files on disk. What a columnar-oriented database will do is you need to define a schema. So you have to define your columns. And then when you store your data, you fill out a column with the specific data. So, if your log line had, 10 key value pairs, those 10 keys become the columns, and then you fill out the values. And where this really matters is on how the data is queried and accessed. So if you say with Loki, if you wanted to say column A, I want to get the sum of all of the values from column A, we would have to read the entire row for every one of those log lines, which means reading a whole bunch of data that wasn't part of the ask of the query. And we essentially scan all those, add up all the values, return a result. Where a columnar oriented database, because the data is stored, the column data is stored contiguously, sounded close, as a continuous block. So you can go grab the block of an entire column and say, I want all of the data from column A, and it's stored basically physically together. So, Loki stores the rows physically together, and we have to read the whole rows. You can pull back that column. And so now you can return just a subset of the data that's relevant to your query. And that can, seriously simplify the amount of moving of data that you have to do and searching of data you have to do. It becomes a bit interesting when your query touches all the columns, because then it's like, is that better than a row-oriented database? It might be a wash. But also column-oriented databases often do things like compute statistics on an individual row. So like that's another form of an index where they might index things like the max, min, average, some basic statistics on anyway, some basic statistics, and they then you can just go query that header, and maybe if you were just looking for the max value over a time range, you can get it by querying a couple bytes, right? Like, so they have some real advantages for storing well-structured data, and if you have access patterns that only look for pieces of it.
So is Prometheus a columnar database, or is it also row-based?
Ooh. Can I answer this question?
It's okay if you don't know. I was just wondering.
It's more of a columnar than a row database. I'm trying to think of what their actual storage format looks like.
So the reason that I'm asking is that you can really send a log can be anything. It can be, a number, it can be a string, it can be objects or arrays or lots of different things. So, but I think in the example that you mentioned where you're adding up something in a single column, so that's numbers, that's metrics. And in that case, even though Loki could do it, it sounds like you're saying that's not what it's optimized for. And maybe that's why something like Prometheus would be better for that. It's not that Loki can't do it, but maybe if it's columnar, then that kind of makes sense why Prometheus would be a lot faster.
No, you're spot on here. I think I would get yelled at if I called Prometheus a columnar store, but it's similar in the idea that it essentially does two things. It stores metric data for one metric in proximity, right? So that it gives you the ability to query just the data from one metric, just like you would pull a column back. but also metrics do another thing, which is really nice. Like you could, based on what we talked about before, I could consider metrics as an index of logs. So they're and Loki has this thing called recording rules where you can run continuous queries that generate a metric and then write them into, Prometheus or Mimir so that you have metric data, because again, it's about using a smaller set of data to answer the question you're looking for. So what metrics also do, which is really nice, is they normalize data over time. So if you imagine you have, you have a log entry for every order your company processes, and you get increasing volumes. That's more and more log entries. But if you wanted to just track the number of orders over time, maybe by a few dimensions like success and fail, if you turn those into a metric, they get sampled as counters at normal intervals. And so now as that volume sort of ebbs and flows, the amount of metric data you're storing is consistent. It doesn't change. So it's in one sample every 15 seconds or minute or whatever. And that it has a value that corresponds to that counter. So that makes querying metric databases way faster and easier over much longer periods of time, because their data is consistent over time. It's also much smaller. And like we mentioned, it's stored in a way that makes it easier to access. So it's, in my opinion, logs is the only true observability signal. So metrics are a really nice optimization on log data. And then, the next step is you just instrument your apps directly with metrics, right? So you don't have to do this log line to conversion thing, but metrics are a really nice way. In fact, this is how sort of Loki was always meant to be used, was, using metrics tools to narrow down timeframes and systems that were affected by whatever you're searching for, that you can then translate into your query to Loki. In Grafana, we've kind of made this as easy as we can. Just, click a couple drop downs and you can start searching your logs. But you've now used, essentially the metrics database is a giant index for narrowing down the time frame and some of the systems you're after, so that Loki doesn't have to search such a big data set.
So I've got a really beginner question, because we've used like the index of time series quite a lot, and this was like my biggest mistake with Loki, and I feel like I should know this. But so I come from like previously life Influx Data Land, which was a metrics database, and we had this notion of like the timestamp was God. This is our primary key, and if you inserted a row into Influx that had the exact same timestamp and the exact same tag set or label set, if we want to call it in Loki, then we would instantly overwrite the fields in that row. Now, is that the same in Loki, or is it an append-only store and you would append under that? There'd be another log for that timestamp and that label.
Yeah. So I don't know. We made a decision here that might have been the wrong one. It's certainly, I don't know. So anyway, the way Loki actually works here is it's complicated in a couple directions, but the simple one is if you send two log lines with the same timestamps down to the nanosecond precise, exact same, and they have the exact same content, we just store one copy. The other is thrown away. It's just, it's automatically deduplicated on ingest. If you send two log lines that have the exact same timestamp down to the nanosecond, and they have different content, we store both. So you can have numerous log lines at the same timestamp. And this in practice happens a lot more than you'd think, because a lot of systems don't have very precise clocks, or they don't generate precise timestamps in their log output. So if you only have a second's precise log line or timestamp, you might get, hundreds or thousands of lines at the same 1 second timestamp. So we didn't want to like throw those logs away. It just becomes hard now because they have the same timestamp. So what order did they come in at, right? Like, and when you go to query them, it makes our life at query time way harder. And there's one other level of where you can, if you send older data to Loki, it will ingest it under some circumstances. Or there's just kind of some rules you have to follow, but you can send older data. And if that had the same timestamp as the newer data and the same content, they would all get stored. But at query time, any exact duplicates are removed. And that's because Loki uses a replication factor system to run as high availability. So we actually have exact duplicates in storage as part of replicas in some cases. And so the query engine always just removes exact duplicates.
See, I mean, I kind of agree with the logic, because I feel this is kind of like a leisure thing, right? Where it's like you would want to keep all of your information rather than, drop or overwrite potential critical information. So, I mean, I think that was my learning curve here, because I was like, I feel like I should use labels and streams in anger because I'm going to lose my data otherwise. But once I discovered, no, it's like append only, I'm like, actually, well, I can sparsely use my labels a lot more often, and then just deal with it at query time when I'm basically parsing, whether it's like with FMNT or JSON. And then, because I've noticed that, and it's probably a good segue a little bit onto querying if we have time, is kind of like, how does this sort of piping operation work? And it kind of like, you feed that string line right into that piping, and then it almost creates new labels for you in Grafana land, which you can utilize in the UI there.
Yep. Yeah, again, I don't know if for better or worse, I struggle to sort of understand sometimes if decisions that we made were good, bad, or there is no good. There's only, but yeah, the way the parsers in Loki work is, if you had a JSON log line and you do pipe JSON, all of the keys and values become parsed labels. But we don't really disambiguate that in the UI. And we kind of go back and forth about whether we should or not, because they functionally, in terms of how the query works at that point, it don't matter. The only time that it matters is whether or not you can put them inside of the curly braces in the query language. And then we're questioning whether or not should we even need curly braces, and like, do we even need a query language? Like, a lot of feedback that we get is folks don't like learning query languages. I can empathize. I think our query language is interesting. It was essentially, heavily inspired by Prometheus, because that was how we got our entry into the world, right? We rode on Prometheus's coattail. Oh, that's not there's a Bjorn Ravenstein gives a really good lightning talk on the pluralization of Prometheus. So we followed rode on the coattails. And so as a result, we were looking to gain folks that were familiar with using Prometheus to use our tools. So the query language, the labels, all that. And then, fast forward to today. And, I think a significant portion of our customers have never used Prometheus or Loki users, right? And so now that query language is sort of maybe more confusing, right? Because it's like, oh, I have to learn Prometheus and Loki. Like, yeah, kind of. I guess the benefit is you learn Prometheus too. So if you look at it on the upside, but really the goal here isn't about learning query languages, it's about getting your logs. So we're always trying to figure out how to. So we have works in place now to try to make more user interfaces that are kind of point and click. And but the query language is really great. Like there's sort of nothing you can't do. It does get a bit weird because it embeds like the entire Go templating language in it too. And I don't know, like that kind of got that for free because we write in Go, but in retrospect, it's kind of awful. Like the queries you end up writing can be sort of hard to see. So it's like, on the one hand, we didn't have to solve that problem because we just used one that existed, but I don't know. This stuff is kind of hard, and the growth of the project has been. We're just trying to keep ahead of it. It's been great, and it's been super fun. It's just in hindsight, what would we do different? And like, yeah, I don't know, maybe the query language, but then again, probably not, because that allowed us to get where we were at the time. So it's really maybe about what do we want to do now, and how do we. So. If you all are learning Loki, I am interested in your feedback on what you found easy or hard, or like what we could do, to change things. Coming from an Influx background, I've never spent much time with Influx, but I know they've got a few query languages, and have finally, I think, settled on SQL, which we get a lot of asks for, and maybe this is my fault because I have no interest in writing another SQL query ever again.
Yeah,
Maybe that's
I
not
think
the
we
right
could.
opinion, but
Yeah, we could do an entire like conversation about this in itself. But for me personally, I actually feel, and I'm probably really going against the curve here, is I don't mind learning a language that's dedicated to the database that's been built. So for like LogQL here, it makes perfect sense for Loki and the way it operates. If you try and skin SQL across the top of it, it's going to be a very interesting. You almost have to go,
yeah.
okay, how does Loki work underneath to then be able to write the most efficient or usable query on top. So it was, yeah, I people can scream for SQL all they like. I think sometimes you just need it to solve your problem, rather than like just because you like SQL.
Yeah.
So I know there might be a very
that
I might get shot down for that one, but
I think that when it comes to time series data and trying to query and visualize time series data, SQL is a terrible language for this. I could defend that statement if anybody wants to fight me. However, and this is why like PromQL and LogQL, like the way the functions work, it's better at this. It's simpler and easier to write a query on time series data. However, anything that you're doing that's trying to do something that's more analytical, like count distinct, or counting and grouping, or sort of looking at maybe joining data, right? Like SQL is a much better language for that, right? So that's, I think, why folks like it's both, because I mean it is kind of how it was built and what it was built for, right? So it's like that's, I think, usually the divide where, like, I will say yes, like if you're trying to do more of those types of queries, it's hard to do that in PromQL and LogQL. Vice versa, if you're trying to query time series data and represent it as such, it's much easier to do that in PromQL and LogQL.
Okay, so maybe we could talk about some best practices for querying data from Loki as well. So you
Yeah.
already mentioned that when we're writing data to Loki in the first place, we should try to use fewer labels, like the fewer the better, pretty much. And the labels that we do use should be ideally very long lived. Probably, things don't often last forever, but as long as possible. So something that's not unique, like a trace ID, you said,
Yep.
and also something that people would actually query for. So not like house numbers, more like postcodes.
Yes, you've got it. In fact, maybe we can throw a link. I've wrote a few blog posts over the years on labels, but recently, a couple months ago, I revisited, and I even spent, I mean, I don't know how many hours trying to build some really poor looking animations that I think are actually quite helpful. It's just embarrassing how long it took me to make them. So yeah, you
Those
nailed
blog
it though,
posts will
right?
be
That's
in the
the
description below.
yeah. The on the ingestion side, yes, exactly what you said. So on the query side, and then writing good queries, the first thing I would normally tell folks is the number one tool. Like, there's no sort of magic here. Like, the label selectors you use directly determine the amount of data you're going to query. I've used analogies like a table of contents in a book. Like, we call it an index, it is an index. But like the back of the book we talked about as being like a reverse index, where it's very specific and it tells you exactly where to look. Loki is more like a table of contents, where like your streams might define a chapter. This is maybe not the best analogy, because I don't know, I like the house analogy now. I'm gonna figure out how to adapt that one, the address analogy. But I know what town I want to look in. I know but the more specific you can be off the start, the less searching Loki has to do, the faster your result is. Now, you might not be able to narrow it down, right? So then if you can narrow your time frame down, right? So if you have to search through all of the addresses in a town, or in a state, if you can narrow the time window down, you'll search through less data. However, maybe not. So then the next thing that becomes really important is filtering. So filter expressions in Loki are these pipe equals or exclamation equals, which means must contain or does not contain. Use those right after your label selectors. We do optimize queries a little bit when they're out of order, but it's just kind of good practice to always use filter expressions. And this is the next fastest thing that Loki can evaluate, right? So when we read a log line, we very quickly can check to see if it matches the filter expressions, and then stop processing it immediately if it doesn't. And that means you then save the processing effort of something like a parser if it doesn't match your query at all. And then from there, it's like the more complex you make your query, probably the slower it takes. Like, there are Loki queries that are run that will process like 30 billion log lines, and if you think about like how absurd that is, it's really hard to, I was trying to do an analogy to all of the pages in Wikipedia one time, right? Like, it's like, if you imagine basically that query probably searches every line of Wikipedia, right? Like 30 billion lines is a massive number. Loki does it fast because that will execute on thousands of computers. Like, we will parallelize queries like that across 2,000 machines, all of them processing. But at the end of the day, it's going to come down to however many CPU instructions it takes to execute your query on every log line. And even though they're in parallel, you're still going to get this sort of longer, long tail problem. Whichever subquery takes the longest kind of dominates your query time. So the simpler you keep a query, the better. But yeah, use labels, narrow down your time range. Continue to narrow your query as well too, right? Like, if you have to search very broadly, if you find a result, immediately narrow your time frame to just that time frame, right? Or add a few labels to narrow the result to make subsequent queries faster.
So on that note, then, what takes priority? Does it is it narrow down the time first and then it checks labels, or does it check like the labels first and then checks the time range? Kind of like.
Yeah, it's a good question. So time range first. So the way Loki actually stores data is the index file that we build gets stored with the log lines in object storage. And so when you run a query, we'll go fetch the index file for it. We do one per day in most cases. So if your query spanned 7 days, we'd have to go fetch the index file for each of those days. And then within that, we would then look at the label matchers to figure out which of these chunks we have to go read. So narrowing by time just means there's less index files you have to look at. So it's a bit of a, in practice, it's probably sort of moot, it's more like the amount of actual data you have to search is really going to dominate how long like if you're going to search 10 gigabytes or 10 terabytes, like, whether that 10 terabytes was over 24 hours or 7 days is probably not, as important as if you could turn it into 10 gigabytes over 7 days with a label selector, or 10 gigabytes over 5 minutes, or it's usually probably more about the volume.
So in the address example, so let's say we're looking for a specific bit of mail or mail that was sent to Jay within a certain time. Is it better to like jump straight to the postcode, or should we go like let's filter out by country first and then by state and then go down that way?
Yeah.
Or is it just better to jump to the more specific one?
If you have the way that it actually looks up in Loki, it will just be the most specific label matcher that effectively determines technically the combination of them, I guess, could be more specific. I don't know. Well, is that true? The way I would answer your question is just use the most specific label that you have, if you already know the postal code, and that's going to make the sort of data that you have to search the smallest, then yeah, go with that. You aren't going to really gain anything by adding more label selectors in there. In theory, you could actually maybe make it worse, but I don't know that I want to introduce that kind of complexity to folks. Just usually the easiest thing is to just use like it's really common in our queries, because we build out dashboards a lot of times with template variables, to have drop downs for things like clusters and namespaces, and but they might also have a very specific label selector. It's like you only need that one, but folks always just kind of fill out all of them, or you're not going to hurt anything by adding more labels generally, but you really only need to pick whatever your most specific is.
Okay, so in that example, so first you would suggest we narrow down the time range. So we'd say I'm only interested in the mail that Jay has received in this last week. And then second, you would say like I'm not actually going to say where you live, but like, only
Doxed.
search
Got
for
him.
this postcode, which I know that Jay lives in. And then after that, you said, then do the filter expressions. Like maybe Jay has a brother that also lives on the same street. So then maybe let's filter out Jay's brother's name or something. And only then would you parse it.
Yes. Yep. You're essentially the pipelines of a query are executed for the most part sequentially. So, whatever you put in the front gets done first. So the filter expressions being up front will just allow you to completely, bypass. In fact, Loki can sort of short circuit that extremely quickly. Like if we, as soon as we read the line out of the file, if it doesn't match the filter expressions, that's it. It's just ignored forever. And doesn't take place in any other part of the processing. So it saves memory and CPU and, and I will say there's like an example of this. Again, we try to optimize a little. It's just hard to write query optimizations that don't cause you problems sometimes too, but for example, if you were, say there was a specific key or a value in a JSON pair you were looking for, and that value was, cat or something like that. Now, in your JSON object, cat might appear multiple times, right? And you only want to know if it's like, parent equals cat, right? This is a bad analogy. I'm going with it, but there might be like sibling equals cat or, cousin equals cat or something like that. But you only want to match parent equals cat. So ultimately, you're going to do a JSON parse, and then you're going to do a filter that says, parent equals cat. But you could upfront just do a filter expression that says pipe equals cat. And that makes sure that the log line at least has to have the word cat in it before anything else is done. So that can be a nice optimization to just make sure. And like,
Wait. Oh my days. So that means you don't even have to pass it at all. You can literally just do a search on that.
Yeah. So if that line doesn't have cat in it at all, then we don't ever have to run the JSON parser on it or do any other comparisons. So that's, and like I said, Loki will do some of this for you. It kind of sees those cases. I just tend to be explicit about it. Honestly, a lot of times, I think the interesting thing about any database is there's some amount of data where it doesn't matter what you do, right? Like if you use a relational database with less than 1 million rows in it, there's almost no query that you can write that won't execute in less than a second. Like it just doesn't matter, right? If you get more than 1 billion rows, you probably have to have an index to query that table, right? You can't just row scan it. You probably might need to query on multiple indices. You might need to use hints or something, right? Like at some scale, it becomes hard to query. So it's similar here with Loki, right? Like most of the time for most folks, like just kind of write your query. I would say it's not until you're trying to query terabytes of data in a single query that you really want to care about optimizing to that level. I mean, certainly, hundreds of gigs too. And again, I'm talking about the Loki, the way we run it, which has lots of compute tied to it. If you're running your own Loki, your mileage may vary on what that amount is, where you have resources that make it quick. So always the general good practices are there, but I don't want folks to walk away feeling like they have to, like I got a bunch of Raspberry Pis back there with Loki on it. And like, I can query over several days worth of data because it's, it's maybe 10 gigs a day of data. I don't query the whole thing. Like, so it is a bit of, and that's maybe the interesting part about Loki is because it is a horizontally scalable system. You can make those numbers quite big, right? Like you can, we regularly run queries that are over terabytes of data that can process in, 20, 30 seconds, maybe 45 seconds. It depends. But queries less than 100 gigs are, sub-second or second long. Like on my Raspberry Pi, that wouldn't be true, right? It's going to be a bit grumpy if I tell it to query a terabyte of data. But yes, so the tips, like generally, filter first is just kind of a good practice to get into no matter what. That optimization of filtering before JSON parsing and then filtering again after JSON parsing, certainly use that if you're querying huge data sets, but you don't necessarily have to all the time.
That's a new one for me. I did not know that was possible just to do purely on the log line before you did any parsing. So you learn something new every day.
Yeah, and I'll also throw another one in there. Always prefer, the filter expression like pipe equals and exclamation equals, so contains or doesn't contain, to the regular expression equivalent. Regular expressions are just hard. Like I was joking with Dima from the Pyroscope team, who's one of the creators of Pyroscope, about how much of the world's CPU is spent on executing regular expressions.
Yeah.
It has to be like 50% or something like that. So, they're kind of a necessary evil, but like if you don't need one, like for example, if you wanted to search for, it'd be better to write an expression. We have this OR syntax you can use now where it's like you could put two variations of the same search term than it is to use a regular expression, because that's faster. Like regular expressions are generally slow. Never use the case insensitive variant. We made this very hard to use in Loki, not by design, but it is the way that it is. And maybe it was a good side effect, but like you put in parens $I inside a regular expression matcher and it does the case insensitive match, and it's just so slow. It's just so much extra CPU work. So it's faster to search for two variants of the same case with like pipe expressions than it is to do a regex matcher that's case insensitive. So my general advice is, avoid regular expression. Should be a last resort. I mean, we use them all the time, right? Like I'm not saying don't use them like constantly. I wrote really one of the worst regular expressions I've ever had to build the other day, like because I needed to solve a problem with it, right? It's going to limit maybe how much data that I can search with it or how long it takes if it gets really complicated. And then I might be grumbling on the other side because, we're running these clusters. It's like, oh, that's a lot of CPU. I wonder what's going on over there.
Right.
Okay, those are some really good tips for querying logs. We are out of time, but thank you for coming on and giving us some context about Loki. Really appreciate you coming on.
Awesome. Thanks for having me. That was super fun.
We have a bunch more content to look forward to on Loki. Jay and I have already done a 0 to Hero Loki series, which we are still adding to. I will link to that, plus all the documentation for Loki, the forums for Loki, and all of that in the description below. I guess thank you everybody for watching. Thank you both for joining me.
Yeah, thank you, Nicole. It's awesome.
Yeah, thank you.